All right, Physics 30 is continuing along with curved mirrors and lenses. All right, let's take a look at some diagrams we can draw here. So it says, for each, sketch the image, describe its characteristics, and show where the eye is located. In other words, where the viewer would be. So we're looking on page 86. Okay, here we go. All right, so we want to make sure we're picking from our list. A couple pages back, it has the idea of step 1, step 2, and step 3. Well, step 1, we got to pick one of these types of rays to start and then follow up with a secondary one, okay, or a different one. So let's try it out. I like for this kind of one here, I see that I have a concave mirror and drawing a ray that is parallel to the principal axis like this, okay? And then it reflecting predictably through the focal point here, okay? Now draw it long enough because we can have it go far enough over here, and that's fine, okay? And you can, of course, draw an arrow showing the direction that it's moving along its motion. All right, now what I'll do is I'll pick the, I believe the third choice from that previous page, from page 84. So I'll draw a ray that goes straight through the focal point and then reflects back parallel to the principal axis, kind of like that. All right, now I want you to notice that these two rays did meet at this location right here. So this would be the location where the image is found. So if this is the object, then this would be the image right here. And again, its height. Now you can see its image characteristics. Well, it's upside down. That would be called inverted. Its size is larger. Okay. And is the image real or virtual? Well, in fact, it would be real because the two rays do meet. So remember, we have the image, right? You describe its size, its attitude, and its type. So the size would be larger. The attitude is inverted. And the type is real. Okay, let's take a look at the next one. Okay, so here we go. We're going to do the same thing. Now, it's not going to be reflection, it's going to be refraction. So I'm going to draw my first ray straight at the convex lens, and then, of course, straight through this focal point here. It's concave, convex, geez. Okay, convex, right? Convex and then concave. I got it. All right, now the second one here, I might want to just go, well, let's try the second option from the previous page there, where it just goes straight through the optical center. Okay. Again, no refraction really happens at all. There's a little lateral displacement, but the lenses are fairly thin, okay? And then we have our image that's created here. Looks to me like it might be, oh, a little bit, it's probably a little bit bigger. It's just outside. It should be, I think it should be just a little bit outside here, okay? Just like this one's outside over here. They're kind of the same sort of thing. Okay, so I'm going to go with the larger, the inverted, and the real. Okay, remember our object here and our image down here. All right, let's take a look at the diverging mirror or lens. Hold on just a minute. Back to this first part here. We had to show where the eye was. Well, where would you be standing looking at it? Well, it seems to me that the eye would have to be right here. Okay. Dun, 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 dun. Obviously right here. And then over here, where would the eye be? Well, you'd have to be on this side. Okay. Showing a little bit on the retina there. There we go. Okay. I should say the cornea of the eye. Okay. Anyways, the eye would be out here because that's where you'd be kind of looking, your perspective. Okay. All right, how about a diverging mirror in a lens? So now let's go ahead and realize that what we're doing here is we are continuing along with the same sort of plan as before, but now when it reflects off, in this first case, it's going to reflect off as though it came from this point. So we draw a dashed line down here to show, right, a virtual ray, and then we show like a real ray coming off that direction. Okay. Now another one that's really nice, just like the optical center one up here, this one here will reflect, right, straight back along its path if we draw it this way. Okay, so it'll go straight at the mirror here, and then straight back along that path, but we'll draw a dashed line on the other side. I'll draw it all the way to that center of curvature. Now our image should be right here. Okay, so the object here, the image right here. You can see that the size is smaller. You can call it diminished. Okay? The attitude is the fact that it is upright. Sometimes people call upright erect. Okay? And then the type, well, two virtual rays met, and so it's a virtual image. All right, and the same thing is probably going to happen here, is my guess, right? So I'm going to continue along, same basic idea. Okay, draw it straight to the center. And then, of course, it's going to diverge. It's going to diverge out as though it came from this location right here. Okay. And so it diverges out like that, and then a dashed line back to this. And then another one that's really good is straight through the optical center, which would be right here. There's other ones you could do. You could go along like this, okay, and then have it when it hits the mirror goes straight that way. There's not very much difference between the two, okay. I should show that. I maybe should show that, I guess, but this one kind of makes the ray get in the way. I'm going to just go with this one here. Now there are, like I was talking about, that there's three different ways to do this, right? Then you can see the fact that one of the other ideas or processes could show just verify the answer, I guess. Okay. So you can use some as a check. Here's your object and here's your image. And you can see that the same sort of stuff there. What I was going to show is the fact that you can do this, right? You can show that if you draw this one directly at this focal point here, so go straight to there, and then it goes parallel to this axis here, kind of like that. Then if you draw a dashed line back the other direction, it should intersect pretty much in that location. That's another way you can check it as well. All right, moving along here. Converging mirror lens. Object beyond C. Okay, so let's try and speed this up a little bit. Even though the mirror doesn't quite go to there, I'm going to assume that it's going to go to that spot. Okay. There we go. Whoa. A little wild there. And then here. Straight along this axis here. There we go. And you can see these two met right in this location here. So put that arrow for this ray in the wrong spot, didn't I? Object and image. And then this one here as well. And then we'll just tidy up with the final image characteristics. Right to there, through here. And this one straight through the optical center. And the image. Object, image. Okay, so the image characteristics, you can hear that the size is smaller. The attitude is inverted. And these images, as you can see here, must be of the real type. All right, converging mirror lens, the object inside the focal length. Okay, so this one's an interesting one here because we know the converging mirror has a lot more going on than the um, diverging mirror, for example, and the diverging lens. Diverging mirrors and lenses only really have simple characteristics. It's always going to be upright, smaller, and virtual. Okay, so here's what I'm going to do. Here I'm going to go ahead and just continue the process. Light hits the object there, and then comes back along here. You know the object's in the way. It's kind of a common thing though. Okay? And then what I can do is I can just draw this straight through here. In other words, right at the mirror and then right back along that length. Now I'm going to extend these rays, oops, not with a solid line, with a dashed line all the way back here. And this one here, straight back. I know this paper's small enough, but it's trying to give us at least a little room to do this. Okay? If I continue these two virtual rays back, then in fact I get this object that does meet essentially, yeah, this one's a little off, I guess. Maybe that would have helped a bit. I get this image that is very large. Okay, so here's your object, here's your image. Now, of course, the image has to be virtual, but the size here, oops, whoa, size is larger. The attitude is, of course, upright because the type is virtual. Okay, and then the same thing with this one here. So what I'll do is I'll go ahead and go straight at it and through here. Kind of seeing where I'm going here, you might be able to figure out this. Okay? That we've got to draw a line going back this way. Dash line, of course. There we go, something like that. And then this one here, straight through the optical center would be a great thing to do. Okay. And then dash lines coming back here. They intersect right about there. So the object and then the image. I know I'm kind of running out of time here, so let's just kind of wrap things up with what I needed to do here. So the last thing I needed to do was, of course, show that the eye would be in these cases. Well, obviously, when you're looking at a mirror here, the eye would have to be here. Over here, right, you have an object, you're looking at it, you're seeing a small little virtual image, and so really the light has to pass through to be able to see it properly. Okay, you never have the object on the same size as you are, and then the lens far away. Light has to pass through it, and then of course reflect off the mirror. So that always gives you an idea of where the eye should be. Same thing with right here. The eye has to be over here, and in this case, the eye would have to be here. Okay? And then because you look through a lens to see an object. And then this one here, you'd have the eye, and of course the eye here. All right, thank you for joining me with those examples. Okay.